Electromagnetism is a fundamental force that powers our modern world. From the lights that brighten our homes to the personal devices we use every day, electricity is all around us. It is easy to take it for granted, but the study of electricity has fascinated humans for centuries, leading to some of the most important discoveries and innovations in history. Whether you are interested in the physics behind electric circuits, the practical applications of electrical engineering, or simply curious about the way electricity shapes our daily lives, the topic of electricity is sure to spark your interest. So let's dive in and explore the fascinating world of electromagnetism. The ancient Greeks were aware of the static electricity, which they observed when rubbing fur on amber, but they did not have a thorough understanding of the nature of electricity as a whole. The modern understanding of electricity and its origin can be traced back to the 17th and 18th centuries, with the work of scientists such as Alessandro Volta, Michael Faraday, André Marie Ampère, or James Clerk Maxwell. Electric charge is a fundamental property of matter. It can be either positive or negative. All particles are either electrically positive, electrically negative, or electrically neutral. Think of an atom made of protons and neutrons in its nucleus and electrons revolving around it. Electrons have negative charge, protons have positive charge, and neutrons are electrically neutral. One of the properties of electrical charges is that particles with like charges repel each other, while particles with opposite charges attract each other. The net electric charge of atoms is usually zero because they have the same amount of positive and negative charges. But it can happen that you remove or add electrons to the atom, making it become electrically charged. This is what we call ions. Anion is an atom that has lost one or more electrons and therefore is positive. Cation is an atom that has gained one or more electrons and therefore is negative. Consider a glass rod that you rub on a cut fur. By doing this, you are transferring electrons from the fur to the rod. This charges the rod negatively. If you put the rod close to a bunch of small pieces of paper, the charges inside the paper will feel the effect of the charged rod. The electrons in the paper will want to move away from the rod, while the protons in the paper will be attracted to the rod. The paper moves and gets attached to the rod, like magic, but being science. Electrical charges feel a force without contact. We'll talk about this force in coming lectures. Electrical charges are quantized, and the minimum charge is that of the electron. This means that we can only have multiples of the charge of the electron, either positive or negative. The proton has the exact same charge as the electron, but positive instead of negative. Charge is measured in coulombs, and the charge of an electron is 1.6 times 10 to the power of negative 19 coulombs. Another thing to keep in mind is that the charge is a conserved magnitude. You end up with the same charge as you started, although these can be redistributed. Welcome to the fascinating world of electricity, and may science be with you.